This section should be another review for you, and it's about the quadratic equations, which are the next step up from the linear equations. And so you recall that a linear equation is a polynomial equation with degree 1. That means the largest exponent which appears is 1 in a variable. Well, here, our largest exponent is 2. And these types are called quadratic or second degree equations. And so we'll see in a minute where the word quadratic came from. But let's go ahead and tackle this problem. Now, there are several techniques for solving these, and we're going to review them all in this section. And the easiest when you can do it is when you can factor the equation. So here we have x squared minus 2x minus 8 equals to 0. And it's the left side will factor rather nicely as x minus 4 times x plus 2 equals to 0. So this factoring technique you learn in algebra has really two purposes. There are main purposes for it. One is simplifying fractions, and the other is in solving equations. And we'll see this again in a later chapter when we tackle equations, polynomials, which have higher degree than 2. For now, we're just going to concentrate on second degree. Anyway, I think the word quadratic comes from, when you factor this, you get four pieces. And so I'm guessing that's why the term quadratic evolved the way it did. In any event, notice that my equations start off equal to 0. And that's important because we always try to organize these second degree or quadratic equations so that one side equals to 0 and everything on the other side is simplified. And there's a purpose for that. Because in order to solve this, why does factoring work on this? You see, we're multiplying two numbers here. If you think of these as these quantities, these parentheses, as two different numbers, the product of two numbers equals to 0. And what happens when you multiply two numbers and you get 0? Well, that means one of these has to be 0. And have you ever seen it otherwise? Have you ever seen two numbers multiplied together and that equals 0, but both of these numbers were not 0? I have seen that, but not in the real number system we're working in. In our real number system, algebraically, it's called a field, and a field has a whole list of special properties to it. And one of them is results in what we call the zero product property, which means that the only time you multiply numbers together and get 0 is if at least one of these numbers is 0. All right, so what we're doing, this whole technique of factoring exploits that zero product property. And it says that, okay, well, the only solution to this problem can occur if either this factor, x minus 4, is 0. Let me fix that. Or the other factor, x plus 2 equals to 0. And those are the only two possible solutions to this problem. And now here, if we solve for x, add 4 to both sides, I'll get 4. And here, if I subtract 2 from both sides, I get negative 2. So my answers are 4 and negative 2. So there we go. And it would be easy to check this. You could plug those back in. Normally, nobody screws up this part, coming down to here. And so the thing you want to check is the factoring. And that's where people make mistakes. A lot of students, I think, will just put numbers up there and think it looks right and then proceed to get the wrong answer. It's because they didn't check their factoring. So let me just make a pitch for that. Let's check our factoring. This is x squared plus 2x minus 4x. So negative 4 plus 2 is negative 2x, and then minus 8. We did factor it correctly. So if you want to do well, check your factoring. Just do it. I still check my factoring, and I've been factoring a long time. Many years. So, all right, so that's when people screw up a problem like this, is because they factored wrong, because they were too lazy or careless to check themselves. But after that, the finish of the problem is relatively easy. All right, well, so here's a problem with two answers to it. And the reason we get two answers is linked to the fact that it is a second-degree polynomial. And so, for example, if we had an x cubed in the problem, then we might expect to get three answers to it. That's not always a hard, fast rule, though. It's possible to get a quadratic equation with one answer to it, or even zero answers in terms of real numbers. And there are some of these which, when you try to solve them, the answers require that you use a different number system called the complex numbers. And we're going to look at that in the next section. All right. Now I want to make another comment about these quadratics. And let me make a little room here. If you were to think of this problem as a graph, for example, if you're looking at y equals 2x squared minus 2x minus 8. What is this shape? Well, this shape, and you're just going to have to take my word for it right now, we are going to study these in some detail pretty soon, but this shape is what's called a parabola. And it's an arch shape. It either loops up or arches over. And in particular, this one would cross the x-axis at 4 and at -2. And so it comes down, goes back up again, like so. And as a matter of fact, it crosses the y-axis here at -8. So this is the y-intercept point. All right, so these 2 points are called roots, the roots of the equation. So that's a term we're going to use quite a lot a little later on. So the roots of the equation are the same as the x-intercepts of the graph, which are the same as the solution to this problem when you set that equal to 0. And why is that? It's because if I set this equal to 0, then I'm trying to find out where is y equal to 0. Well, y equals to 0 right along the x-axis. So anyway, this is sort of the nature of these quadratics. Their graphs, if you look at it this way, their graphs are parabola shapes. And because parabolas dip down and come up, or go up and then come down, then they can cross the x-axis in 2 places. So you can get 2 answers to these. If it came down and just touched and went back up, then you'd have 1 answer. All right. And if this graph never did touch the x-axis, if it, for example, stayed above the x-axis, then we would use those complex numbers I mentioned that we're going to study shortly. All right, so I wanted you to see that. And one other little comment before we move off of quadratics, off the parabola shape. I can demonstrate a parabola right here if you watch the pen as it flies through the air. The shape that it traces in the air, I hope that came out well on the video, the shape it traces is a parabola shape. Of course, it's upside down from this, but you can look at the physics of these problems and see that that's exactly where that can show up. So why do we study these? Well, parabolas are one step up in complexity from the lines, linear equations, or straight lines. So they're one step up in complexity, and they show up a lot in physical things. For example, that object flying through the air is a parabola. That's just one place where you see that. All right, I'm going to erase the board and put up another problem for you. Here's a problem that is not strictly speaking a quadratic equation, but cut. Now here's a problem that is not strictly speaking a quadratic equation, but it will turn into a quadratic equation once we simplify the fractions in it. So, and we see that a bit in this course. In fact, there's a whole section devoted to problems which are quadratic in form, even though they're not truly a quadratic equation. Because remember, to be a quadratic equation, it has to be a second-degree polynomial. And this isn't even a polynomial. So here's a problem. Solve 1 over x minus 1 plus 2 equals negative 2 over x minus 2. So we've seen problems like this before already. And our first order of business is to clear the fractions. And so I look for the common denominator, and that would be what? Well, there are two different algebraic denominators. Number 2 has a denominator 1, but I'm kind of ignoring that. So x minus 1 and x minus 2 are the two different denominators. So that is what I'm going to multiply the equation by. And this will clear the fractions. So when I multiply this by the first part, the x minus 1's will cancel, leaving 1 times x minus 2. So that's just going to be x minus 2 plus, and then when I multiply this times the number 2, I have 2 parentheses, x minus 1, x minus 2. And then finally over here, the x minus 2 will cancel this x minus 2, leaving negative 2 times this term, x minus 1. So now we're going to start to see it turns into a quadratic equation, because when we multiply this stuff together, we're going to get x squared. So let's go ahead and do that. And I'm going to do this in 2 steps, because one mistake students make is attempt to do all this at one time. And that's not a good idea, because I'm multiplying 3 different numbers together, and I'm not capable of multiplying 3 things at one time. Or very seldom I can do that. So here I'm going to first multiply the binomials together, and then I'll worry about the 2. So 2 times this product, and that's going to be x squared minus 2x minus x, and then plus 2. And then over here on the right, when we multiply through, I've got negative 2x plus 2. So this part will simplify to x squared minus 3x plus 2. And now let's multiply it by the outer 2 on the outside of the parentheses. And we get x minus 2 plus 2 times all this, 2x squared minus 6x plus 4 equals negative 2x plus 2. Alright, so now it is a quadratic equation. It's a second-degree polynomial equation, but in order to solve it, we want to simplify it first. And the typical thing to do is to simplify it into descending powers. In other words, I want to put everything on the left side, where I have an x squared term, an x term, and a constant number equal to 0. And we always look for that 0 on one side, because we want to take advantage of that 0 product property. Alright, so I have 2x squared, and let's see, this is going to be minus 5x, and then plus 2 equals to negative 2x plus 2. And here, if I subtract 2 from both sides, the 2's will cancel. And if I add 2x to both sides, effectively bringing it to the left side, then I'll get my 0 on the right. And on the left, I'm going to have 2x squared plus minus 3x, because I added 2x to negative 5x. Alright, so here's my equation in its simplest form. And I need to do a little erasing to make room here to finish the problem. So I'm going to keep the original problem up here. Alright, so we're down to, and let me recopy this up above, 2x squared minus 3x equals to 0. All right, now that is a quadratic equation. It is missing the constant term. You know, well, not really. It's a plus 0. But I don't write 2x squared minus 3x plus 0. But it's there. There is a constant term there. But this can be solved by factoring. And because we can factor the x out, and that would leave 2x minus 3 equals to 0. And so in factored form, we can take advantage of the zero product property and set each factor equal to 0. And that immediately gives us one answer of x equals 0. And my other answer will come from here. And if I add 3 to the right side and then divide by 2, I'll get positive 3/2 as an answer. So we're done. We have these answers. Let me write in one place here. X equals to 0 and also 3/2. So there's my two answers. Now, it's particularly because it's started off as a fraction. It's as we discussed in the previous section, you really ought to check it, or at least make sure that your answer doesn't cause division by 0. Well, it doesn't, and I have checked this answer. I worked this out. In fact, you know, to come up with a problem like this where it factors nicely is not an easy thing, but I worked one out. Here it is, and I know these answers will work in this and here. So there you go. There's a quadratic form which turned into a quadratic equation once we did a little manipulation to it.